Hello guys, I'm Kashyap, and in this video we're going to solve question number 9, palindrome number. So, given an integer x, return true if x is a palindrome and false otherwise. Now, before we answer the question, we have to understand what a palindrome is. So a palindrome is basically a number or anything that is the same when it's reversed. So for example, take 121, and if you reverse it, it's going to be 121. So this is a palindrome. This is a valid palindrome. If you take ABA, that's a palindrome, because its reverse is also ABA. That's a valid palindrome. So now, we're supposed to find if, the given integer is a palindrome or not. Here's how I would do it. And this is O of log n time complexity. I'll explain why later. Anyways, so we're going to convert this integer into a string. So we're going to convert that into a string. And once we have that, we can turn this into a list, and we can append each one of those elements into the list as an integer. So if you take 121, its string version is 121, right? And then we convert that to a list with an integer appended. So it's going to be 121. Now what we can do is either you don't even need to convert to a string actually. To an integer. You can keep it as a string. It doesn't really matter at all. But I'll try both ways to see if one works or not. Anyways, basically what we're doing is we're comparing if the reverse of this list is also equal to itself. If it is, then it's a palindrome, and if it isn't equal, it's not. It says over here that negative numbers are not palindromes because when it's reversed, the negative goes on the right side of the integer, not the left side. It doesn't stay in place. So now we know that if x is less than 0, it's false, right? So now that we have our constraints and conditions ready, we can go to writing the code. So I'm going to grab this over here. Okay, so we have our integer x. Now we can just convert x into a string. X string is equal to string of x. And then you can just say, for set up an array actually. Array is equal to boom. And then for I in x string, array.append of I. And then now we can just convert over here, check it. If array is equal to array of reversed of itself, then we just return true. Return false. So over here, now we also have to check if it's a negative or number or not. If it is a negative number, then we're going to do the fastest execution. So now we can check over here. If x is less than 0, if x is less than 0, then return false. There we go. So this is one way. The other way is to just do this. Well, it really doesn't affect anything. In fact, it makes it sort of slower, but not really. Let's run some test cases, and let's see it. And let's just print it first of, whatever, 121. Okay, let's run this. There you go. See if it works. Solution is not callable. It's weird. Oh wait, I just realized. It's palindrome, there we go. That should fix it. If you run this now, true, nice. Now if you do negative 121, boom. False, that works. And now if we do, even if you do a string, let's say ABA. In fact, if you did put a string into the old one, oh wait, oops. Actually, let's just scrap that. In fact, let's just go back. We don't even need to look at extra types. Just stick with the integer and solve an integer. Can you solve it without converting the integer to a string? We're gonna cover that in another video, not now. I'm gonna link it once I posted it in the description below. So we're gonna solve the follow-up part of this question later on. But let's run this question. It should work. Now I'll explain the time complexity of this code. So over here when you are appending it, and actually when you're converting it to a string and appending it, you're gonna get O of log n. That's your time complexity. Your time complexity over here will be O of log n. And that's in line 5, in fact, or line 5 all the way up to line 8. Okay. Now, in line 9, when we're checking if it's a reversed, that would be O of n, because you're just comparing every other element. That would be O of n in line 9 to 10. Actually, it's a 9 line. So that's how our time complexity is going to work. It's O of log n over here. Now let's just copy this. Boom, run that, see if it works. It does. Let's just run this over here. And that works, nice. So our time complexity is O of log n, and that is the solution for the first part, not the follow-up of palindrome number, question number 9. And I'll see you guys in the next one.